Okay, so in this video, I would like to prove that if we have a sequence an which is bigger than 0, and if the sequence n times an converges to some non-zero limit L, then it must be that the sum of an diverges. Okay, so the first thing that I want to do is I want to actually claim that L is bigger than 0. So this is maybe not super difficult to see why this would be the case. We know that an is bigger than 0. And we know that n times an is just natural numbers times an. So this is like a1, 2 times a2, 3 times a3, and so on. So all of these are going to be bigger than 0 as well. And so if all of these are bigger than 0 and they're converging to a limit that's not equal to 0, then it must be that that limit is actually bigger than 0. Okay. So that's the first thing. The second thing is I want to claim that if we choose n sufficiently large, say big N, we know that for all n greater than or equal to big n times an has to be bigger than L over 2. And you can maybe see this if you imagine your number line. Your 0, and L is somewhere out here. But I know that if I pick any epsilon, eventually the sequence n times an is going to be sitting in this neighborhood. L minus epsilon, L plus epsilon. So, in particular, if I choose like epsilon equal to L over 2, then, this point, L minus epsilon would be L over 2. And I know that the sequence is eventually going to be sitting in this neighborhood. So I know that the sequence is going to be bigger than L over 2. Okay. Now, the reason this is useful is because if I know that this is true for all n greater than or equal to big N, I also know that an is bigger than L over 2 times n. Okay. So now, if I look at my series, if I look at the sum of an, I can actually divide this series right here into two different sums. So this is going to be the sum over n equals 1 to big N minus 1 of an plus sum over n equals big N to infinity of an. Okay. And I know that this sum right here is bigger than this sum right here. Well, it's kind of weird. And that's because of this right here. So in particular, I know that because this sum is bigger than this sum, then either both of these sums need to converge or both of them need to diverge. That's just by the comparison test. But I know that this sum is actually a multiple of the harmonic series, right? Because I have the L, which is just a constant, and then I have L over 2. So this is actually just a multiple of the harmonic series. So I know that this sum has to diverge right here. And I know that this sum here, this is just a finite sum because the upper limit of this sum is just n minus 1. So in particular, now I know that the entire sum of an has to diverge. And yeah, that's it.